Hello and welcome to Cruising Through Calculus. My name is Alex and today we're going to be looking at some real-world problems with calculus. Now these problems are almost always about an object that is moving either up or down or right or left, and you have to figure out a variety of things about that object. So let's jump right in with our first problem. Our first problem says, a particle moves along the x-axis given by the position function x of t equals t cubed minus 3t plus 3, and t is greater than or equal to 0. Now, it doesn't say it up here, but we are going to be measuring this in meters and seconds. And the only reason I'm not writing it down is just so I can get extra room down here. Now, let's look at the first part of this problem. It says, what is the velocity at t equals 4? Okay, we have our position function up here, so in order to find velocity, we need to use the derivative. So let's go ahead and let's find the derivative of this function up here. Once we find our derivative, that will give us our velocity. Just need to use the power rule for the first one and the second one. Derivative of a constant is 0, so we get 3t squared minus 3. All right, now we can plug 4 in for t because we have our velocity equation now. All right, so here we've got 3 times 16, which is 48, and then 48 minus 3 is 45. So our velocity at t equals 4 is 45 meters per second. The next part of this question says, when is the particle at rest? Well, a particle is going to be at rest when the velocity is equal to 0. So let's take our velocity equation, which I wrote over here, and let's set that equal to 0. Okay, so we're going to add 3 to the other side, then we're going to divide both sides by 3. Then we're going to take the square root of both sides. Every time you take a square root, remember you do have to include the plus or minus, so we actually do get two answers here. But if we look back up at the problem, you'll see that t is greater than or equal to 0. So what we're going to do is we're going to pick t equals 1 here. So in other words, at 1 second, the particle is at rest. The next part of our question says, when is the particle moving left or right? So in order to figure out when the particle is moving left or right, we first need to know when the velocity is equal to 0, and then we're going to see what happens around those points. That's because if there's a positive velocity, that means the object is moving to the right, and if there's a negative velocity, that means the object is moving to the left. Now luckily we did figure out when the velocity was at rest, it was at 1 second. So what we're going to do is we're going to draw a number line, we're going to put 1 second on here. I'm also going to include 0 because t is greater than or equal to 0. And then we're going to pick a couple of test numbers that are around here. We're going to plug them into the velocity equation, and we're going to see what kind of answers we get. Do we get positive answers or negative answers? Okay, so here are my two test numbers. Let's take 1/2 and plug it into our velocity function. Then we'll take 2 and plug it into our velocity function. Now, we only care if we get positive or negative answers, so you don't have to get the exact answer over here, although if you do have a calculator, feel free to do that. But let's take a look here. 1/2 squared is actually 1/4. 1/4 times 3 is 3/4. 3/4 minus 3 is definitely going to give us a negative answer. On the next one, we have 2 squared, which is 4. 4 times 3 is 12, and 12 minus 3 is definitely going to give us a positive answer. So over here on our number line, we know that from 0 to 1 it was negative, and then from 1 onwards it's positive. So that actually tells us our answer. Our object is moving to the left from 0 to 1, and it's moving to the right from 1 onwards, like that. The next part of this problem says, what is acceleration when t equals 1? Well, in order to find acceleration, we start with our position function, and we find the derivative, which gives us velocity. And once we have velocity, we can find the derivative, and that'll give us acceleration. So let's go ahead and find the derivative of this over here, and that will give us acceleration. Now, if you want, you can think of this as the second derivative of position, or just the first derivative of velocity. In either case, we're about to find acceleration here. Okay, so using the power rule, it looks like we're going to get 6t. So in order to figure out what acceleration is when t equals 1, well, all I need to do is just plug 1 into my acceleration formula over here. So 6 times 1, which is 6. And so that is the answer. The next part says, what is the displacement and total distance from the interval 0 to 5? Well, all right, let's start with displacement because that's usually easier. Displacement just means comparing where you start to where you end up. So here we're going to start at 0 and we're going to end at 5. So let's figure out what happens when we plug 5 into our position equation and 0 into our position equation. Let's start with 0 just because that'll be easier. If I plug 0 in for t, I'm just going to get 3. Now if I plug in 5, this is going to be a little bit more difficult. We have 5 cubed, that's 125, minus 3 times 5, which is 15, and then plus 3. So that should give me 113. Okay, so all we need to do is take 113 and subtract 3, and that'll be our displacement. So that means 113 minus 3 is 110, and this is in meters here. By the way, in our last example, I said that the answer was equal to 6, and I forgot to tell you what the units are. The units, because this is an acceleration, are meters per second squared. Don't forget to include your units because teachers do want that. Okay, let's continue here. We have our displacement. Now it's time to find the total distance. Finding total distance is usually more difficult than finding displacement, but it can still be done. So here's what we're going to do. You'll notice that the velocity was negative from 0 to 1 and then positive from 1 onwards. So what that means is that the particle was moving to the left for a certain distance and then it was moving right for a certain distance. So we need to take into account both of those distances. So here's what we're going to do. We know already what the starting value was. It was x of 0 equals 3. We also know what the ending value was. X of 5 was 113. Well, notice that from 0 to 5, there was a point when it changed directions because it was moving to the left and then it was moving to the right. And that happened when t was equal to 1. So here's what I'm going to do here. I'm actually going to plug 1 into this equation up here. So we're going to get 1 minus 3 plus 3, which is just 1. Okay, so here's what this means. Let me show you visually. When t was equal to 0, we start at 3. Then we move to the left, and we do so until we get to 1 second, at which case we were at a distance of 1, or an x-coordinate of 1, if you will. Then we're moving to the right from that point onwards. And we keep moving to the right until we get up to 5 seconds, because that's our ending time, and that is where we reached our ending point of 113. So it looks something like this. We start here at t equals 0, then we move to the left, and at 1 second, we start moving to the right. And just coincidentally, at 1 second, we're at an x-coordinate of 1. And we keep moving to the right, and keep moving to the right, and keep moving to the right until we get all the way over to here at t equals 5. Now, I hope you can tell this is definitely not drawn to scale because this 113 should be like all the way over there. But we can figure out what all the distances are now. You see, when we went from 3 to 1, that means his displacement was negative 2. Then he had to re-travel that distance back from 1 to 3 again. So the displacement between 1 and 3, or 1 and here, is 2. And then from this distance onward, we are going to get a distance of 110. Right? The displacement from our starting position to our ending position. So all we have to do is make sure all of these are positive and then add them together, and that will be our total distance. So our total distance is going to be, let's make that one positive. Those are already positive, so we don't have to worry about that. It looks like 114, and then this will be in meters. So the displacement was 110 meters, but the total distance traveled was 114 meters. And that's because we traveled to the left for 2 meters, then we traveled back right for another 2 meters, and then we traveled 110 meters for the rest of our journey up until 5 seconds. The next part says, when is the particle speeding up and slowing down? Well, in order to answer this, we need to compare velocity and acceleration together. Now, as it turns out, we actually know quite a bit about velocity as we were answering the previous problems, but we don't know quite as much about acceleration. So let's take a look at acceleration and let's create the same kind of graph we made for velocity. Let's start by figuring out what makes acceleration equal to 0. Well, that's a pretty simple one in this case. It's just 0. Then let's create a number line here. Let's put our number 0 on here. And because t is greater than or equal to 0, I don't need to worry about what's over here, but I definitely do need to worry about what's over here. So let me pick a test number. Any number will do. And let's take that number and plug it back into our velocity, or excuse me, our acceleration equation. This is pretty easy. If you take any number over here and multiply it here, so like 1 times 6, we're going to get 6, which is a positive answer, like this. So, in other words, our acceleration appears to be always accelerating from t equals 0 onward. So how do we figure out when the object is speeding up or slowing down? Well, let's create a table and put all the information that we've just found together. All right, I've constructed a velocity acceleration table. Now what I'm going to do is I'm going to use my acceleration and my velocity graphs that I created over here, and using all the numbers that I found, I'm going to create them as intervals over here. So for example, velocity was from 0 to 1, and then from 1 onwards, and acceleration is just from 0 onwards. So if I kind of combine these two, what I end up with is 0 to 1, that's one of my intervals, and then just 1 onwards. Now what I'm going to do is I'm going to look and see where was velocity positive and negative, and let me write it up here. Velocity was negative from 0 to 1, and then positive from 1 onwards. Acceleration was always positive, so I just get to put positive and positive like this. This is perfect, because here is what we're looking for. If acceleration and velocity have the same signs, so if they're both positive or both negative, that means that it's speeding up. But if they have opposite signs, so one is positive and one is negative, that means it's slowing down. So take a look here. I have an interval where both velocity and acceleration have the same sign here. They're both positive. So that means this is the part right here that's speeding up. On the other hand, they have opposite signs here on this interval, so that must mean it's slowing down. So the answer to our final question here is, let's start with speeding up. It's speeding up on the interval from 1 to infinity, and then it's slowing down from 0 to 1. And these are all in seconds, by the way. And there we have it. Our next problem says, a slingshot launches a pebble up vertically by the position function x of t equals negative 4.9 t squared plus 100t plus 6. Now, it doesn't say it up here, but everything is measured in meters and seconds still. Like I said, I just didn't want to include that. That way I had as much room as I could when I'm answering these questions. All right, let's take a look at the first part here. It says, how long does it take the pebble to reach maximum height? Well, in order for the pebble to reach maximum height, the velocity has to be equal to 0. And this is because the moment the pebble is launched up into the air, immediately it's going to start slowing down because of gravity. And it will start slowing down and start slowing down and start slowing down, and then eventually it actually will reach an exact moment where the velocity is 0, and then it has to turn around and start falling back down. So let's start by finding our velocity equation here. We do have position up here, so if we find the derivative, we're going to find velocity. Okay, we get negative 9.8 t plus 100. So now what I have to do is take this and set it equal to 0. Subtract 100, divide both sides by negative 9.8, and that will be our answer here. And I've already plugged this into a calculator, and I got 10.2041 seconds. And that is the answer to our first part. The next part of this question says, what is the pebble's maximum height? Well, I know how long it takes for the pebble to reach its maximum height, and I have a position function up here that'll tell me where the pebble is at any point in time of my choosing. So why don't we take 10.204 seconds and plug it in up here, and that should give us what the maximum height is. Now, I've already plugged this into a calculator, and I got 609.915 meters, like that. The next part of this question says, what is the velocity and speed when it hits the ground? Well, okay, first I need to know when does it hit the ground, and then I can figure out the velocity and speed. I actually have an equation up here which will give me the height of the object at any time t. So what we're going to do is we're going to take that equation and set it equal to 0 here. Now, in order to solve this, we're going to need to use the quadratic formula. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, you're definitely going to want to take this one and plug it into a calculator, which I did. And you're going to get 2 answers. That's because of the plus or minus right here. So one of the answers is negative 0.0598. And the other answer is 20.468. Now, this is a real-world problem, and we have to imagine that somebody's asking us what is the velocity and speed when it hits the ground. And if somebody said, hey, when does it hit the ground? And you told them it took negative 0.0598 seconds, that doesn't really make much sense. So we're actually just going to ignore this answer, and we're going to use this answer here. That is how long it takes to hit the ground. So how do I figure out the velocity and speed? Well, I have an equation that will give me the velocity at any time of my choosing, and we just figured out how long it took the object to hit the ground. So let's take 20.468 and plug it into our velocity. 20.468. So it's going to be negative 9.8 times 20.468, and then plus 100. Now, if you plug that into a calculator, you get negative 100.586. And this is in meters per second. Now, that's your velocity, and it is okay for velocity to be negative. In this context, it means that the object was falling down when it hit the ground. Definitely makes sense since we're talking about a slingshot launching a pebble. In order to find speed, all we need to do is take our velocity and just make it positive. Believe it or not, it's really that simple. You can even think of it like finding the absolute value of velocity. And there we go. That's the final answer to this problem. You need to be really comfortable with the idea that if they give you position and you find derivative, you're going to be given velocity. And if you find the derivative of velocity, you're going to get acceleration. Each piece here is going to give you a little bit more information about the problem. And depending on what they ask you, you might need to use one or two or maybe even all three at once. So for example, in one of the problems, it asked us for the velocity when it hit the ground. Well, in order to answer that, I would need to know how long it took for the object to hit the ground so I could plug it into velocity. So that means I had to go back to position and set that equal to 0 because 0 is ground level. Then once I figured out how long it took for the object to hit the ground, I could plug it in and get my answer. There's a lot of times when you have to do these kinds of things. You might even have to compare velocity and acceleration, for example, to figure out when a particle is speeding up or slowing down. So be sure to read the question carefully. Be sure not to get too overwhelmed by everything, because there are a lot of questions. And just answer things one step at a time. I think that if you take your time, you'll find that it isn't too bad. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.